Hello all, in this video I'm explaining you about candidate elimination algorithm. Before getting into the coding part, first let us see what is the problem statement. So problem statement says for a given set of training data examples stored in a .csv file, implement and demonstrate the candidate elimination algorithm to output a description of the set of all hypotheses consistent with the training examples. Here we need to use CSV data, and for that CSV data we need to implement and demonstrate the candidate elimination algorithm. We need to train the machine using the candidate elimination algorithm by giving the data which is stored in a .csv format. Okay, and finally what this algorithm has to give, what is the output we should get, is the best hypothesis, so that that hypothesis fits into all the examples whatever the machine encounters, and finally it will classify in a efficient manner. Before getting into the algorithm part or the coding part, we will understand what is the basics we need to understand before learning the algorithm. Okay, so what we should understand is candidate elimination algorithm incrementally builds the version space given a hypothesis space H and a set E of examples. Here it is going to incrementally build the version space. Version space is nothing but it is a space which consists of both general and specific hypothesis. The examples are added one by one. Each example possibly shrinks the version space by removing the hypotheses that are inconsistent with the example. So, when you give the examples one after the other, what happens? The version space is going to shrink. It is going to keep only the hypothesis which is consistent with the example or consistent with the sample. If it is inconsistent, it is going to remove that. The candidate elimination algorithm does this by updating the general and specific boundary for each new example. Here it is going to it is going to maintain both the boundaries. One is general and also the specific. And this algorithm can be considered as an extended version of Finder's algorithm. If you are familiar with Finder's algorithm, then this is very easy to understand. In this algorithm, we are going to consider both positive and negative examples. But in Finder's algorithm, we used to consider only the positive examples, right? That we used to neglect the negative examples. So here we need to concentrate on both positive and negative examples. We are not supposed to neglect any examples in Finders. That is one of the disadvantage of Finders algorithm. Okay, and if you encounter positive example, then you need to just apply Finders. The algorithm works in a way how Finders used to work. Okay, it is going to make more specific hypothesis into more general form. If you have a positive sample, then it works like a Finders algorithm. If you have a negative sample, then we need to make it as most specific. Okay, you will understand this concept with one example. Before getting into example, first we will try to understand the basic representations of this algorithm. Here we have general hypothesis. Here we are representing the general hypothesis using the question mark. That symbol we are using, and the question mark, what it signifies is the number of attributes, and specific hypothesis with a null value. Okay, similar to the Finders algorithm. And what is version space? It is an intermediate of general and the specific hypothesis, and it has both the spaces. And coming to the algorithm, first step is you need to load the data. Here, what kind of data we need to consider? That is the CSV data. And next is you need to generalize hypothesis, means you need to initialize both general hypothesis and specific hypothesis. In find us, we used to consider only the specific hypothesis initially, but here you need to consider both general and specific hypothesis. And step 3, for each training example, you need to consider each example. If it is positive, then it works like find us. So what find us will do? It will check with the attribute value. If the attribute value is equal to the hypothesis attribute value, then both are same. No need to change anything. If it is not same, you need to replace with question mark. You are making specific hypothesis into general. If the example is negative, what you should do? You have made it general initially, and that has to become more specific. So the concept is very easy here. Initially you are taking both the hypothesis, one is general, another one is specific. If you get positive example, then you should update the specific hypothesis, just like find us algorithm. If you encounter negative example, then what you should do? You have to what is that? General hypothesis has to be more specific. You need to make that as more specific. And we will consider this example and we'll see how to make the specific hypothesis into general and general hypothesis into specific. See, this is a data set which consists of 6 attributes, that is sky, temperature, humid, wind, water, and forest. And output is again yes or no. That is the binary output. Okay. And here, what is it? This data set is saying based on this weather condition, a person can decide to go out or not. Okay. Based on this, he's going to decide whether to go out or not. According to this, what the first example is saying, that sky is sunny, temperature is warm, humid is normal, wind is strong, water is warm, and forest is same. So based on this conditions, what a person will think? Yes, he can go out. Like that, we have 4 different set of samples. And initially for that data, what you should do is you need to initialize one general hypothesis and one specific hypothesis. Specific hypothesis is declared in this form. It is initialized in this form. And in general hypothesis, you can see for all the 6 attributes, you have placed 6 question marks there. This all 6 attributes you have again, because it is more general. This has to be become more specific, and specific, this has to become most general. Okay, you take up one instance, that is the first instance, and you check what is the output. That is the positive output. If you have positive output, then you should go with the find us algorithm. According to find us algorithm, what you should do is whatever the specific hypothesis you have to check that value with the given attributes. And yes, this is the general specific hypothesis you got. And um, what is that? General hypothesis is equated to G. It remains same. There is no change. Again, you take up instance 2. Here also, you have a positive output. You should only check with the specific hypothesis. And according to this, what you have? See, both are sunny and both are warm. See, temperature in first hypothesis also warm, in second hypothesis also warm, and sorry, in second example also it is warm. And when it comes to humid, in first example it is normal, and in second example it is high. So that one is replaced with a question mark. You have to make that as more general. And next is what? Strong and strong, warm, same and same. There is no change in the attribute value. You should keep it as it is. And next, you consider instance 3, that is G3. According to instance 3, you got a negative output. Now you have to check whether what general hypothesis, you should make that as specific. You just check with the hypothesis value. See here what you should do is you should compare example 3 with example 2. Okay, there rainy is there, and in example 2 what you have, sunny. So both are different, and here what you are trying to make it as, from general you have to make that as more specific. So you change rainy to sunny, and cold and warm, again you have to make it more specific, change that to warm. And next is high, humid is high. In second example also it is high. Wind, in this third example it is strong, and also in second example it is strong, like that. And when it come to forest, it is change, and here the sunny, here in the second example the forest is same. Okay, yes, that value you should make it as more specific. And coming to this general hypothesis, you observe in G3, see we have changed those values to specific. Okay, and when you get a negative output, no need to change specific hypothesis. It has to be S2 only. That's why you're changing, that is you're equating S3 to S2. Okay, and coming to instance 4, again you have got a positive output. There you should again check with the specific hypothesis, and general is equated to G3. And finally this is the output we got. Okay, after iterating with all the examples, this is the output we got. And here general is this, and specific is this one. Here we have replaced 3 attributes with a question mark, and here the first 2 attributes. In this way the hypothesis has become from more general to more specific. Okay, and coming to the coding part, let me execute the program, and explain you the program. Okay, here I'm importing CSV as a coding part. First I'm importing CSV, because why I should import CSV is we need to work with a CSV file. So, and next what I'm doing is I'm opening this file, and I'm reading that, and uh, see CSV file, I'm reading the data, and yes, I'm putting that, means I'm directing that to the list. And finally, see, this is how, yeah, I'm not printing that anywhere. And next is what? S is equal to data, and for I in range, and length of S for J in range, and length of S, it is reading the data here. And again, see the output what I get, steps of candidate elimination algorithm. It has to read, see, steps of candidate elimination algorithm for first instance. For first instance, as I told you, we should have both the hypothesis, that is one is specific, another one is general. See, for specific, what you have equated means you are fetching the data, that is the input data, whatever you have read from the CSV file. And G, you are replacing all the attributes with a question mark, and that is how it is representing here. And it has to go through all the samples present in the data set, and that's why this for loop and these lines are included here. And as a result, see, print steps of candidate elimination algorithm, and you're indexing that, and also and based on the number of samples present in the data, it is printing. See here, steps of candidate elimination algorithm 1, and here first one is specific, next one is general. And according, and here the data set what I have considered is, wait, I'll show you. Yeah, this is the data set I have considered. Here again, the same data set I have considered here, which I took to explain you about the candidate elimination algorithm, that example. And here also same thing, I had the person is going out or not. Okay, and according to this example, first instance says it he can go out, that is a positive instance. Second one is negative. Third and fourth are positive. Okay, so according to that, this program is working. So first one is positive, that's why only that specific hypothesis has changed and general hypothesis remains same. When it comes to second sample, what happens? Again, the general hypothesis remains same. Wait, let me check. Yeah, again here yeah, sorry, I have considered different data set there. Okay, I'll show you that data set. Yeah, this is the data set I have considered here. What is the data set? First two are positive, next one is negative, and final one is positive. So according to that, it is not changing with the general hypothesis, that is specific hypothesis has changed, and in the step 3 it is changing the general hypothesis, it is making that to more specific. And in the final step, that is the final example, that is example 4, there it is a positive output, so only the specific hypothesis has changed and general hypothesis remains same. And finally, these are the outcomes. One is, this is the final output, and that is the specific hypothesis and general hypothesis. Okay, with this, I hope you understood this concept. Thank you.